It's not very pretty. Yeah. Fractions just mean pieces. Pieces or parts. Okay. When you have a numerator, when you have a fraction, the number on top is the numerator. The number on the bottom is the denominator. And what do these mean? I think that's part of the problem too. What do they mean? Okay, the denominator is how many pieces in a whole. Okay, so like if you had, for example, a pizza, how many pieces was that pizza cut into? Okay. And then the numerator is how many pieces you have. That's how many parts made up the whole pizza. And I pigged out, and I ate 7 pieces of pizza. So I have 5 pieces left. That's my numerator. That's how many pieces I have of that whole pizza. So the first thing I want to do, if I'm going to make a fraction to represent this figure, is I need to figure out how many total pieces there are. So there's 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. So 24 pieces, right? And that is my denominator. Okay. Now I can decide, do I want to make a fraction of the shaded part or the unshaded part? Unshaded. Unshaded? Shaded, okay. So I count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 24ths would be shaded. Now we haven't reduced this yet. We can, but I'm not going to talk about that just yet. Which would leave us how much not shaded? Yeah, 9, right? Because it has to add up to 24 to be the whole thing. So the shaded and the unshaded will always add up to whatever your denominator is. Do you remember we talked about the different kinds of numbers that there are? And I said there are whole numbers and natural numbers and integers and rational numbers. Rational numbers are also known as fractions because a rational number's definition is any number that can be written as a fraction. So fractions are also called rational numbers. And so properties of fractions will also be properties of rational numbers. Okay? So the first one, if I have a denominator, I'm not going to use a because that looks like 9, doesn't it? Let's do x. If I have a denominator of 1, that's the same thing as a whole number. Yeah, it's one of the properties of fractions, yeah. Okay. If I have a numerator of 0, it's the same thing as 0.
Can we use the 0 subset? Can you do that one with another number? Can you do that one with another number?
Like, what do you mean, like put a 3 on top? Yeah, but it won't equal 0. It'll only equal 0 if there's 0 on top. Yeah. Okay. If you have a 0 in your denominator, you are undefined. Okay. If your numerator and denominator are the same number, you equal 1. If your numerator and your denominator are both negative, you are positive. 2 negatives make a positive. If you have a negative out front, if you have a negative, gosh, I can't draw an X for so. Okay, if you have a negative out front, that is the same thing as having a negative up top, which is the same thing as having a negative in the bottom. Okay, these are all the same.
Okay.
This is the most proper form.
It's just placed in front of the whole thing, right?
That yellow doesn't show up, does it? Yeah, it's the most proper form is to have it in front, but none of them are wrong. Okay, and here's the difference. See this? This is 2 negatives. 2 negatives make a positive. Each of these only has 1 negative. 1 negative is negative.
So you can put it,
Proper fractions have a numerator that's smaller than the denominator. Okay, so these are proper. And they can even be big. I can have 250 as long as I have something bigger on the bottom. Okay? That's proper. You're smaller on the top than on the bottom. Improper fractions, the numerator is larger than the denominator. So we take these same exact things, but maybe we flip them over. Okay. Now, if I have a proper fraction, this has 3 parts and I have 2 of them. This has 17 parts and I have 5 of them. This has 713 parts and I have 250 of them. This is all less than 1. Because 1 whole would have 17 parts, right? But I only have 5. Here, if I have an improper fraction, these are all going to be more than 1. Because there's 2 parts, but I have 3. Right? So I have 2 that makes a 1 whole, and then I have 1 left over. Or here,
division and remainders.
yeah, there's 5 parts, but I have 17. So I have a couple of them. If I grouped them by 5s, I have a couple. These are all more than 1. Okay, a mixed number. Okay, looks like this. We have a whole number like that, right? Attached to a fraction. So 3 2/3. Okay, this is the whole number, this is the fraction.
11/3.
Yeah, 3 is the whole number and 2/3 is the, so if we were talking pizzas, I'd have 3 whole pizzas and then 2 pieces of a pizza that was cut into thirds. This piece right here would have been eaten. Okay. Now, if we want to convert between a mixed number and a fraction, okay, we have to look at this. If each one of these pizzas had 3 pieces, that's 3, 6, 9, 10, 11, right? So it's the same thing as 11/3, but every time you do one of these mixed number problems and you have to convert it to a fraction, you do not want to have to draw a picture and then count up all your pieces. That could be very, like, what if I have 27 and 9/18? or no, 9/19, that's bad, 9/19. I mean, you'd have to draw 27 piece, pizzas and then count it all. That's a pain. So what we do is we move clockwise. Starting with your denominator, you multiply that by your whole number. And then whatever answer you get there, you add to your numerator. Yeah, so it's going to be 3 times 3 plus 2. Yeah, so 3 times 3 is 9 plus 2 is 11. That's that part. That's your new numerator. The denominator stays the same. Yeah. So new numerator, same denominator. So that's the pattern. Start at the denominator, multiply, add, going clockwise. So again, starting with my denominator, I'm going to move clockwise. I'm going to multiply and then add. So I get 4 times 7 is 28, plus 1, 29 fourths. 7 times 11 is 77, plus 3, 87ths. Okay, so darn it. Okay, so I divided. The remainder is my new numerator, and my denominator stays the same. So 17/3 is the same thing as 5 2/3. Oh, I'm sorry. Hold on. Right? Because this is saying 25 divided by 6. That's exactly what a fraction is saying. So I say 6 goes into 25 4 times. 24, and there's 1 left over. This is the whole number. This is the numerator. 4 1/6. Okay. Let's try a -1. Okay. If the fraction is negative, what do you think is going to be true of the mixed number?
Negative.
It'll be negative. So you don't have to deal with any of the negatives, just carry it over. If this is negative, just know that your answer is going to be negative. Don't deal with it during your division. It'll just confuse you. So 4 goes into 39, 9 times, which is 36. So it's -9 3/4. Okay. Proper fraction doesn't turn into a mixed number. 3 times, right? No remainder, so it just becomes a whole number. Okay? So it could be that you just get a whole number out of it. It doesn't necessarily have to be a mixed number. If you get no remainder, it's just 3. Okay. Alrighty. Plotting fractions on a number line. All right, we're going to plot the following fractions. 1/2, 5/6, and -21/5. So first I need a number line. And I need a 0. Okay. Okay, so I have 1, 2, 3, 4, -1, -2, -3, -4, -5. All right. 1/2 is going to be exactly halfway between 0 and 1, right? Five-sixths. If I break this into 6 pieces, this is the 6th piece. So 5/6 is right here. So did you see that? I put 5 lines in between that breaks it into 6 pieces. 21/5 or negative 21/5, it's easier if I convert it to a mixed number first to graph it. So 5 goes into 21 4 times with 1 left over, and it's negative. So if I do 1, 2, 3, oops, those are too far apart. 1, 2, 3, 4, 5, so those are my fifths. So I'm negative 4 and 1/5. Okay, so I need to break this into 3 parts, 3 pieces, my denominator. So I do 2 lines, because this is 1, 2, 3 parts. And 2/3 is going to fall right there. So I'll put a dot on that. Okay. If I do 1/6, zero and 1, I need to break this into 6 pieces. So I'm going to do 5 lines. 5 lines gives me 1, 2, 3, 4, 5, 6 pieces. 1/6 is right here. Let's just do negative 4/5 for this one, just to. I'm going to be between 0 and negative 1. I need 5 pieces, so I'm going to put 4 lines. And negative 4/5 is right here. 4th line over. Fractions follow the same rules as the other numbers. The absolute value of a fraction is always positive. Okay. So it doesn't matter what fraction I put in there, I'm going to get the positive out. Okay. Unless, of course, there's the negative, like on the outside. Remember my lurker? Yeah, then it would be negative. Okay. It's a lurker. All right, so if I have a negative of a positive fraction, that's going to give me a negative. If I have a negative of a negative fraction, that's going to give me a positive, right? Because 2 negatives, oops, that's not very pretty. Make a positive. So the factorization in general okay, so factorization is breaking a number down into its factors. So let's take the number 12. Okay, if I wanted to break 12 down, I can do 1 times 12. I can do 2 times 6. I can do 3 times 4. Each one of these is a factorization. I could break it down further. I could take that 4 and break it down. Also a factorization. However, this one 3 can't be broken down any further. Neither can 2 or 2. This is a special kind of factorization. That's prime factorization. Yeah. So when you break, if you're just factoring a number, you can break it into anything that it legally would break into. Obviously, you can't break a 12 into 7 times 9, right? It doesn't work, but it could be anything. You could say, if I just said, what is a factorization of 12? You can tell me any one of these, and that would be correct. But if I ask you for prime factorization, every number only has one unique prime factorization. So you would have to give me 3 times 2 times 2. And then we'll go over ways to get to that in just a minute. But
Aren't these numbers called prime numbers?
a little bit earlier. Divisibility is the ability to divide evenly. And there are some rules of divisibility that will help you to know if something will divide evenly or not. So, for example, if you want to know if it'll divide by 2, it has to be an even number. So it ends in 0, 2, 4, 6, or 8. Any number, no matter how large or small, that ends in one of these digits will divide by 2. For 3, okay, this one sounds weird, but I'll explain it in just a second. Okay, so let's take, for example, $1,272. Does that divide by 3? Well, we can figure that out really quickly. Take 1 plus 2 plus 7 plus 2. That's 3, 10, 12. 12 divides by 3? Yes. 12 divides by 3 evenly, right? So 1, 2, 7, 2 will divide by 3 evenly.
So if you add the numbers and you divide,
Okay, 5, well, that's any number that ends in 5 or 0. And 10 is any number that ends in 0.
are you gonna test us on this?
No, this will help you to do the next things that we're going to have to do. Because otherwise you're going to be just trying all these numbers to see if they divide. It's easier to go, oh, that's even. I know I can divide it by 2. Or I'm going to add those numbers real quick and see if it'll divide by 3. Rather than test 3 and divide it, and test 4 and divide it, and test like all these numbers. It saves you time. So, okay, let's look at 720. Is that divisible by 2, 3, 5, or 10? Okay, it's even.
10,
Well, it's even, so it'll divide by 2.
5,
It'll divide by 5, so now we just have to check 3. 7 plus 2 is 9,
yes.
so it'll divide by all 3. How about 82? Where did my pen go? Okay, 82 will divide by 2.
No, just 2.
Yep, it won't divide by any of these, will it? Okay. Okay, the next prime number is 3. So we cross out all the multiples of 3. So we have 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66. You see, I'm just skipping by 3s, right?
Yeah,
69,
69.
72, 75, 78, 80, 1, 84, 87, 90, 93, 96, and 99. 4, obviously, we already got rid of. 5, so we cross out all the multiples of 5. And the zeros were already taken care of. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70 is already taken care of, 77, 84 has already been taken care of, and then 13, 91. Thank you. Once you've hit 7, everything left is prime. Factor tree, but I like factor trees. So let's take 220. We're going to make a factor tree. Honestly, I don't know why it's called a factor tree, because trees go like this, and this is really more like factor roots, but okay, whatever. What'll 220 divide by?
10, 20.
10 and 22? That's fine. Personally, I usually do primes, but it doesn't matter. You'll see that we get the same thing. Okay, 22 is 2 times 11, and 10 is 2 times 5, and none of these will divide by anything else. Or here I get 110, so I can do 11 times 10 and 2 times 5. The end of your branches, only the end of the branches, are the prime factorization. Okay, so I'm going to list them. So 220 is 2 times 2 times 5 times 11. And if I multiply that back together, I go 2 times 2 is 4, times 5 is 20, times 11 is 220. Okay. You can also write it with exponents. Since I have 2 2's, it's 2 squared. See why, though, I think they should be called factor roots? Because roots go down, trees go up.
The
But-
number is C.
Hmm?
The number is C.
So it doesn't matter. You don't have to do them in numerical order, by the way. You could have written 2 times 11 times 2 times 5. It's still correct. Because multiplication doesn't have a specific order, right? So I'm not going to count it wrong if I go, oh, you put your 5 in front of your 2. Wrong. No. I have OCD, so I put things in numerical order. You don't have to. Hold on a sec. Okay, so let's try another one. What will this divide by?
1
Won't divide by 2 or 5 or 10, right? So let's go 1 plus 5 is 6 plus 3 is 9. So it'll divide by 3. And then does 51 divide by anything? 5 plus 1 is 6. Okay. So it'll divide by 3. So that's going to be 17. 17 is prime.
17 times 3 is
51. Yeah. And the way I knew this would divide by 3 is I said 5 plus 1 is 6. And 6 will divide by 3. So that's my quick way to check to see if I need to try to divide it.
how did you find that 17?
3 goes into 5 once.
Or you divide?
Yeah, I just did it in my head. And 3 goes into 21 7 times. Okay. All right. So when you're doing prime factorization, this is very useful for all kinds of stuff. It'll help us to reduce fractions. It'll help with mostly with equivalent fractions and things that you have to do with fractions. This is very helpful. So is the divisibility. Okay, equivalent fractions. If something is equivalent, it has the same value, right? Okay, so let's go back to our pizza. Of pizza. And it was cut into 8 slices that are all the exact same size. See, these are all perfect and the exact same size, right? Yeah, okay. And I ate 4 of the pieces.
Wow, you're so greedy.
So I have 4 left over. I have 4 left over? Okay, so I have 4/8 of the pizza, right? But if I look at this, what else does this look like? I have 1/2 of the pizza. These are equivalent. It's the same amount of space. So we can get through 2 equivalent fractions a couple ways. First of all, to check to see if 2 fractions are equivalent, you can either say, oh, well, if I divide this by 4 and I divide this by 4, I get these numbers. That's one way. Or maybe you could go the other way and say, well, if I multiplied this and this by 4. But sometimes it's not so easy to look at 2 numbers and see what you'd multiply by. For example, to tell if these are equivalent or not. Maybe it's not so easy to do. If that's the case, you could cross multiply. 3 times 4 is 12, 6 times 2 is 12. Those are equal, so these are equal. Okay, so there's a couple ways you can get at it. You can either figure out what you'd multiply both the top and the bottom by, or divide both the top and the bottom by, or you can cross multiply and check to see if they're equivalent. Okay, if they are equivalent, you put an equal sign in between them. If you have 2 fractions and you want to check them, and I cross multiply, and I get 49 and 45, I put in this symbol in between them, not equal. Okay. Any questions on that? Right. I'm going to stop here.